So the reason for the number of hybrid orbitals and the number of unhybridized p orbitals in carbon really boils down to the idea that we have the 2s and the 2p orbitals, and in the excited state we in essence have 4 orbitals that we're going to hybridize, and then when we hybridize those orbitals, each one of them is going to get one unpaired electron. So the reason that everything adds up to 4 is simply because of the way we can hybridize this. So if we hybridize our carbon, we hybridize all 4 orbitals, we get 4 sp3 hybrid orbitals, each of which will have one unpaired electron in them, and the VSEPR geometry says that will be 4 hybridized sp3 hybrid orbitals. If we only hybridize the s and the 2p's, then we're going to have 3 sp2 hybrid orbitals, each of which will have one unpaired electron, but then we'll have an unhybridized p that is left over. And so the geometry is built by saying, okay, we've got a carbon, we have 3 hybridized orbitals, so the sp2, another sp2, and a third sp2. We still have this unhybridized p, and where does it go? It goes in the space that's not occupied, so it goes in the unhybridized p, and then every single orbital gets an unpaired electron. So we always have 4 total orbitals in carbon simply because we have 4 orbitals that we're hybridizing. So if we thought then about hybridizing just the s and 1p, then we're going to end up with 2 sp hybrid orbitals, each of which will have one unpaired electron, and we would end up with 2 unhybridized p orbitals. And so again, the geometry here for the carbon would be to put the 2 sp hybrid orbitals 180 degrees because they'd be linear, and then fit the unhybridized p orbitals into the spaces where we would have a py and a pz orbital. And again, each one of those would get one unpaired electron each. So the reason that we always have a total of 4 orbitals, 4 total orbitals from the hybridized and the unhybridized orbitals, is simply because up here we're starting with 4 atomic orbitals that we're hybridizing. So if we hybridize all of them, we'd have no unhybridized p's, 2 of them, 1 unhybridized, 2 of them, 2 unhybridized p orbitals.